Welcome to Learning Math Power Series. It's a calculus topic, and this is the fourth example. And this one is about finding the interval of convergence for the power series summation n equals 0 to infinity minus 1 to the n x to the 2n over 2 to the 2n n factorial square. That's a mouthful. And this is the Bessel function. And from Wikipedia, these are all the uses of the Bessel function. And as you can see, that's a lot. So we'll use the ratio test here, just like in the previous one. Limit as n tends to infinity, an plus 1 over an is equal to limit as n tends to infinity, now we got a big thing here, minus 1 to the n plus 1 x to the 2 times n plus 1, right, over 2 to the 2 times n plus 1, n plus 1 factorial, all that square. That's an plus 1. And now this will be an. Let's extend the absolute value sign more. An is just minus 1 to the n x to the 2n over 2 to the 2n n factorial square. Okay. Now, just a little thing to know that x to the 2n plus 1 is x to the 2n plus 2. So I can write it as x to the 2n x squared. So this is equal to limit as n tends to infinity minus 1 to the n and minus 1, right? X to the 2n times x squared, all that over 2 to the 2n times 2 squared, n plus 1 times n factorial, the whole square, times, and I'll flip the denominator, 2 to the 2n n factorial square over minus 1 to the n x to the 2n. So let's cancel what we can. Minus 1 to the n, minus 1 to the n, x to the 2n. Here we go, 2 to the 2n. N factorial square will also cancel. And what we have left is much smaller than this large expression. So limit as n tends to infinity, minus 1 x squared over 2 squared n plus 1 square. So I'm going to pull out the x squared over the 4, 2 squares 4. Limit as n tends to infinity, 1 over n plus 1 square, and that's very clearly 0. And 0 is less than 1, so by the ratio test, the interval of convergence is and notice that when x squared came out of the absolute value, it stayed x squared, it was an absolute value of x. So by the ratio test, the interval of convergence is minus infinity to infinity. If that's not clear, I can say a couple of lines about it. Let me pull this down here. It's all real numbers. Okay. So we end up with by the ratio test, the interval of convergence is minus infinity, infinity. And so it's essentially true for, this is x square limit n tends to infinity 1 over n plus 1 square, and that's 0. And 0 is definitely less than 1. Right? So it holds for all real numbers. I'm just looking at the previous example to show you what happened there. So over there in the previous example, we ended up with limit as n tends to infinity, an plus 1 over an is equal to absolute value of x minus 3. And so that it was conditional, and it would, so by ratio test, the series converged for absolute value of x minus 3 less than 1. But here we got 0, and 0 is always less than 1. So it holds for all x. Holds for all x, right? And that is why the answer is, by the ratio test, the interval of convergence is minus infinity to infinity. All right, so let's quickly review it. This is the Bessel function. It's an infinite power series. And these are all the fancy applications of this function, why you would need to learn it, straight from Wikipedia. So we use the ratio test. We compute limit n tends to infinity, absolute value of an plus 1 over an. And we get 0, which is always less than 1. So this series converges everywhere. The interval of convergence is minus infinity to infinity. Let me correct that spelling there. It's minus infinity to infinity. That's it. Okay, I'll be doing one more example in series, and then you can tackle some homework. All right, that's it for this segment. See you in the next one.